Hi everyone, this is Muhammad Osama and I'll be talking about current today. So what is current? A current of 1 ampere is the flow of 1 coulomb charge at the rate of 1 second. The definition can also be expressed as I is equal to Q over T, where I is current, Q is coulomb charge, and T is time in seconds. The unit for current is amperes, denoted by A, usually, and this is the diagram that thus summarizes the definition. So current can also be added algebraically, which helps us with parallel circuits. So how is current created in the first place? When there is a potential difference, the charges will move from the higher potential to the lower to achieve an overall neutral system. The charges can move through mediums containing ions, such as electrolyte, or ionized gas as well, such as lightning. So conventional circuits are were believed to be the right in the first place, where they thought that the positive charge carriers caused the flow of current, where in reality is actually the electrons that cause the flow of current. So let's do an example. What is the current in a wire when a net charge of 2 coulomb passes a point over a time of 10 seconds? So using the good old definition and this fancy diagram, I is equal to 2 coulombs over 10 seconds, which gives us 0.5 amperes. What is the current in a wire when a net charge of 512 microcoulomb passes a point over a time of 2 hours? So here, guys, we're going to do the unit conversion, converting the microcoulombs into coulombs and hours into the second, because that's what the ampere is there for. We convert it into the standard units of amperes. So don't forget your unit conversions. So current's relationship with voltage and resistance. Using Ohm's law, we can deduce that current is equal to potential difference over total resistance. Resistance is a property of material which resists the flow of current. Voltage is simply energy per unit charge. So using the water current analogy, we can find that the height of the container containing the water is basically is going to increase the pressure. So more voltage is going to equal to more current flow. Whereas the width of the pipe leading to the exit, if it's shorter, it's going to cause more resistance, so causing the current to flow more slower. So current in series and parallel circuits. The current follows the path of least resistance. In series, we only have one path, sadly, so it can also follow it can only follow one path. In parallel, it will be split and most of the current will take the path of least resistance, as demonstrated by this figure. So example of a current in series circuit. So in series, we know that total resistance is added, so using the formula, we're going to get 50 over 18, giving us 2.8 amperes. Whereas in parallel, we know that we'd have to find the current in each branch, and we can also test that in the least the resistance, it's going to be more current. So I2 is the highest because it's the lowest resistance in that case, and we just add them up. We're going to get 14.2. And this is just a summary of what I just covered, and thank you.